Hello guys, welcome you all to Physics Vedika. Today we are going to cover one interesting concept, and this is a basic concept we are going to start. That's nothing but the distance and displacement. Okay, what is the difference between these two quantities and how to measure them, right? So what is meant by distance? Okay, so distance is basically the path length covered. Okay, it is the path length covered by an object or by a body. uh, it could be anything, right? So how much ever path length it's covered, that is nothing but the distance. Suppose if you are traveling in a metro train, right? So you will be traveling from one place to another place. You can see your train will take several random paths, right? Like it will be moving on the right various places. There will be so many several stops will be coming, right? So it takes a path, and finally you will be reaching your destination, right? So there is a path length, there is a total path length from the starting point to the ending point. The total path length is going to be the distance. It could be several kilometers, right? But when it comes to displacement, you can see this is the shortest path. You know, your train might be covering a zigzag path, but when it comes to displacement, you have to join the initial and final points by a straight line, right? What is the way to get a shortest path? The best way to get a shortest path, not the best way, the only way to get a shortest path is joining the initial and final points. So join the initial and final. When you're traveling in a train from one place to another place, the total path length covered by a body, that will be the your distance. Then when it comes to distance, let's say a car is traveling from one place to another place, right? So this is the total path length covered by the car. Over here you can see this is the total path length covered by the car, and this will be the distance covered by the car. As you can see here, this is the displacement. What is the displacement here? Join the initial and final points by a straight line, then you can see this is the displacement. Initially the car has considered the path like this, but if you want to join the initial and final points by a straight line, then this will be the path. And in this path you can see there is a displacement, or this is the shortest path, right? And you know, distance and displacement both are measured in meters, but distance is a scalar quantity and displacement is vector quantity. So you have to keep this in mind. Scalar quantity and vector quantities. Vector means which has both magnitude as well as direction. Scalar means only the magnitude. So that makes the difference, a lot of difference between distance and displacement. Then comes to, if you go to school and then comes back, your displacement would become 0. You know, you are moving this way and then again you are coming back. So your total displacement would become 0. If you go to school and comes back, the total displacement would become 0 because it's a vector quantity. There is one vector in the positive x direction and there is another vector in the negative x direction. So that's the reason your total displacement would become 0. If you start from a point and then comes back to the same point, then the displacement is 0. So this is the interesting point about displacement. You know, you're going to the school, right? From your home to the school, and then comes back. You can see you are covering some displacement here as well as distance. But what is the displacement? You know, it's an interesting point. The displacement comes to be zero here. Why? Because you are moving to a place, let's say from home to the school, so join it by a straight line. It is having certain value as well as certain direction. Then when you are returning back, you can see it has the same value, and also it is having exactly the opposite direction. So that will nullify both the things. That makes your displacement as zero. Okay, so that's the point you need to keep in your mind. Hope it's clear, right?